Hi everyone. This is our look at percent composition by mass. These are values that express an element's relative contribution to the overall molar mass of the molecule. It's like we're going to say, here's the molar mass, there's all these different elements that contribute to the molar mass, and what percentage of the molar mass is represented by each element. In order to do this, we're going to need the formula first, of course. And then if we take our time and work out the molar mass in maybe a longer way than we normally would, we're going to generate all of the values that we're going to need in order to express each element's contribution as a percent. Now, we could do this for all of the elements in a compound or only one. It sort of depends on what the question's demanding of us. At times, it might take a few minutes. We might be really working slowly in order to figure out the answer, but it's quite doable. Here's an example. Water. It's pretty small, and it's a nice way to get started with this concept. What we need to do is, eventually in the end, we're going to say, oh, here's the molar mass of water, and we're going to express the hydrogen's contribution as a percent. And we're going to do the same for the oxygen as well. So this is not the typical way that I would encourage you to find the molar mass. However, for this particular topic, it's really worthwhile. I'm going to take my time. I need to say, okay, what elements are present? It's a no-brainer. There's hydrogen and there's oxygen. Hydrogen and oxygen in this compound. How many hydrogens? 2. How many oxygens? 1. So fast, so easy. Now, we need to look up the individual atomic masses. We can probably even remember. The atomic mass of hydrogen is 1.01, and oxygen 16.00. And again, I'm pulling those off the periodic table. When I do these calculations, there's 2.02 and 16 for the oxygen. So I end up with, when I add them together, the molar mass of water is 18.02 grams per mole. I take my time to work out the molar mass in this way because now I can see all of the values that I'm going to need in order to calculate the percent composition. Think of it like this. Here's the overall molar mass, and then the hydrogen contributed 2.02 to the 18.02, and we need to express that as a percent. The oxygen contributed 16.00 to the 18.02. Let's also express that as a percent. So I'm going to write it like this, the percent, and then I'm going to put a little subscript H there, just so that I know that that's about the hydrogen. Well, the hydrogen contributed 2.02 out of the 18.02. But I need to express that as a percent, so I'm going to multiply by 100. We need to work that out. What about the oxygen? The percent composition by mass for the oxygen, I'm going to put an O there, of the oxygen. Well, the oxygen contributed 16 out of the 18.02. And again, we need to multiply that by 100 to convert it into a percent. I have my calculator, let's go for it. 2.02 out of 18.02 times 100. Again, a long repeating decimal. I'm going to round it off right now. I would encourage you to always round your percent compositions off to 2 decimal places. The significant digits are a little bit tricky because these are all, they're not counted, they're not measured values. So it almost makes the significant digits moot. most questions will let you know, oh, please round it off to the nearest percent. However, if we're not told, I would encourage you to always take it to 2 decimal places. So this first one, I actually get 11.2097, which I'm going to round off to 2 decimal places. 11.21%. How about the oxygen? It was 16 out of 18.02 times 100. I get my answer 88.790, which I'm going to round off to 2 decimal places. It's 88.79%. A nice double check in the end is that if the question asks us specifically to work out the percent composition for all of the elements, the percentages that we have, they should add up to 100. It's important to say that because we're going to be doing some rounding to have our 2 decimal places, if we end up with the case where the percentages all add up to 99.99 or even 100.01, that's going to be okay. It might not always be a perfect 100 because we're doing some rounding. So, percent composition by mass, it's a way to express each element's contribution to the molar mass as a percent. In order to do that, we need a few things. We need the formula, we need the molar mass, and we need each element's contribution. We could maybe find your own individual way to work that out. If we take our time and really methodically work our way through the molar mass, all of the values that we might need are going to be generated. Don't forget to multiply by 100. These are percents. And I would suggest rounding off to 2 decimal places, or pay attention to what the question specifically says. Sometimes you might get told to round to the nearest percent or express your answer with 1 decimal. There might be some instructions in the question that lets us know how we're going to be rounding. And I hope that helps.